Well, hello, mathematicians, and welcome back. Today we're talking about dividing fractions. And we are going to start with division of a whole number by what's called a unit fraction. And a unit fraction is a fraction that has 1 as the numerator. So when you see division of fractions, I'd like you to ask yourself a question. And that question is, how many of this type of fraction are in this number that I'm dividing by? Okay, so in this case, how many 1/4 are in 2? And for your convenience, you see here that I have divided these whole bars into 4 pieces. So you can easily count and see each of these bars has 4 pieces, and there are 8 1/4 size pieces inside of 2 bars. And you would be correct. If you take 2 bars and divide it into 1/4 size pieces, you will get 8 pieces. But what's going on with the math here? I'd like to know if we can sort of rewrite this a different way. 2 divided by 1/4 is the same as 2. How do I make 2 8? Well, I multiply it by 4, right? So if 2 divided by 1/4 is the same as 2 times 4, there is something very interesting going on here. And I think it's particularly interesting because division is related to multiplication, and this number, 1/4, is somehow related to this number, 4. Now, just as a side remark, I want to note that every whole number, whether it's 4 or 8, every whole number has actually a 1 underneath it. So 4 is actually 4 over 1, and 8 is actually 8 over 1, right? And you can easily note this by just looking at a bar, right? And you see that one whole piece right here, we call it 1. And here's another whole piece, right? When I'm working with fractions, if I cut up the bars, then I say, I have 2 of 2 pieces or 4 of 4 pieces, and that's 1. But in this case, I have 1 of 1 piece. And then I have another of 1 piece. So actually here, I have 2 of 1 piece, right? And that's the way to think about these whole numbers. 4 actually has a 1 underneath it. Now we never really write it like that, although sometimes it's convenient to have that 1 under there to hold a spot. And you'll be doing more of that in this particular chapter, but I want you to know that that is what is behind that number 4. So really, you have this interesting mix of these numbers that are related somehow, 1/4 and 4 over 1. And I would like you to take a closer look at them. What do you notice about them? What stands out to you? Well, if you said that they contain the same number, but in different positions, that 1 is in both numbers, and 1 is in the numerator, 1 is in the denominator, and 4 is in both numbers, 1 in the denominator and 1 in the numerator, you would be correct. And these are called reciprocals. And reciprocals are interesting numbers. They are fractions whose product is 1. Right? So when you multiply them together, and you know that when you multiply fractions, you multiply numerator by numerator and denominator by denominator. Okay? So in this case, 1 times 4 is 4, and 4 times 1 is 4. And 4 of 4 pieces, as we said before, is always 1. Right? So these numbers are reciprocals of each other. And reciprocals are actually inverse numbers. So upside down numbers, if you invert something, or if you hang upside down, you're hanging inverted, right? From your knees, from a bar, whatever. And division and multiplication are inverse operations. So there's some sort of a relationship going on here whereby I can say 2 divided by 1/4 is the same as 2 times 4 and be correct. And I've proved it to myself because I see very clearly that there are 4 pieces in each of these whole bars. There are 4 pieces. And in 2 bars, there are 8 1/4 pieces. So this, how many fourths are in 2, is the same as 2 times 4. So, can we make a rule? I don't know if we can yet. Let's maybe try another few problems and see what we come up with. Suppose that I have here we go. Suppose I have the number 3, right? And I'm going to ask how many pieces the size of 1/5 are in 3 bars. Okay. Oops. Undo that one. Sorry. I meant to do just the pen. So forgive my lines. They're not going to be super neat, but we can try. Whoops. So more or less. Maybe a little less than more. We've got 5th size pieces. And the question is, how many of these 5th size pieces are in 3 bars? All right. So you see in 1 bar, there are 5. And in 3 bars, there are 15. So what is the relationship between 3 divided by 1/5 and 15? Well, if you said to yourself, well, how many fifths are in 3? There are 15, and that's the same as 3 times 5. So you see here again, we're looking at an inverse operation and an inverted fraction. Right? And it just so happens that 1/5 times 5/1 gives us 5/5, which is the same as 1. So what really is going on here? What is at the bottom of this that makes this true? Now we can see that it's true by looking at it. If I divide 3 into 1/5 pieces, I'm going to get 15 pieces every single time. And that is the same as multiplying 3 times 5. So I know that this in fact works. But why? Why is it working? Why it doesn't make any sense until you look at it maybe a little bit differently. Let's take 3 and, I'm going to go ahead and put it over 1 for practical purposes and divide it by 1/5. Now, as you know, division, even the symbol is a fraction, right? The division symbol comes from a fraction. All fractions are division, and all division can be written as fractions. And when you write the division this way, what you have is a complex fraction, a very complex fraction, because you're dividing by another fraction. And it behooves us to get rid of those fractions and make this problem a little simpler. And we can do that by making this denominator 1. And how do we make the denominator 1? By multiplying by the reciprocal. If I multiply 1/5 by 5 over 1, I'm going to get 5/5, which is going to be 1. I did it right over here. Okay? So if I multiply the bottom or the denominator by the reciprocal, I get 1. However, I change the value of the problem if I only do it to the denominator. When you create equivalent fractions, the important thing in order to not to change the value of the equivalent fraction is to make sure you're multiplying by 1, right? So in order to not change the value of this problem, I have to do the same thing that I did to the denominator to the numerator as well. And that means that just like I multiplied by 5 over 1 to get the denominator to become 1, I'm going to multiply the numerator by 5 over 1. Okay, so my new problem becomes 3 times 5 over 1, which is 15. And that happens to be the answer to my problem. Okay, so that's what's behind it. That's why this works. And you've proven to yourself with whole numbers divided by a unit fraction that it works. But what about other types of fractions? How can you prove that? Well, as a matter of fact, you can. So let's get started. Suppose we have 3 paper strips, and these strips are in fourths. Okay, so here's 1, 2, 3, and we only wanted 3, didn't we? So we're taking 3 paper strips and we're dividing them into fourths. So hold on a second. Oops, sorry. I'm not very good at drawing straight lines freehand. All right, there we go. So we've divided them into fourths, and our question is, how many 3/4 are in 3? Okay, so I'm going to, let's see, let me pick a bright color here. I'm going to shade 3/4. So I have 1 3/4 and another 3/4 and another 3/4. Okay, so you see that I have 3 holes, so I have at least 3/4, right? 3 3/4. But what about these pieces right here? Right, this one and this one. You see, I have 1, 2, 3 pieces left over on the ends that it didn't get shaded. And since there are 3, they actually form another 3/4. Okay, so I have 3/4 here, 3/4 here, and 3/4 here. And guess what? A 3/4 here as well. That gives me 4 3/4. Now, I've proven it to myself. I see that it's true that I have 4 3/4 in 3. But can I prove it mathematically? Well, I'm glad you asked, because of course you can. This is the same, remember, as 3 times what? If I change this operation from division to multiplication, what do I do to the fraction? I use an inverse operation and I invert the fraction, right? So if I multiply that out, and I multiply across, 3 times 4 is 12, and 1 times 3 is 3, right? And 12 thirds, I divide 3 into 12, and I get 4. Okay, now I could also have simplified, as I showed you in an earlier video, because 3 goes into itself once, and over here as well. And so I could have said 1 times 4 is 4, and 1 times 1 is 1. So either way, I get the same answer. All right, I'm going to refer you to the guided practice on page 67. I would say do a number of those problems and the hands-on activity as well. Also the guided practice on page 66. I think that you might find that they're interesting problems to do. And you can see if you're getting this well or not. And I'll see you in the next video.